Hello, class. Today we are going to do the complete opposite of what we've been doing this month, and we are going to make equations from roots. All month we've been looking at a polynomial and then coming up with what its roots are. So before we begin, I am presenting you with a warm-up question. This warm-up question should look very similar to something we saw in the algebra review unit. So take a moment and answer this question. All right, now that you're back, some questions I have about how you approach this. Did you do some major FOILing and extreme distributing, or did you do the box method? Now, we did not go over the box method in the algebra review unit, but it is something that's very helpful as we move on because it helps with bigger and bigger polynomials. So what is the box method? The box method is a method of multiplication to the polynomials. So instead of FOILing this like we've been doing, we can do something called the box method, in which we say, all right, we have a binomial times a binomial. So that's 2 terms times 2 terms. I'm going to make a 2 by 2 box, 2 by 2. So then I'm going to take the first one and I'm going to put the first term above the first box, the second term above the second box. And then I'm going to take the next one and put them in their own separate term areas as well. And then you're going to multiply each term to fill in the boxes. So for example, you do x times x, you get x squared in this box. You do x times 2x, you get 2x in this box. 3 times x, you put 3x in this box. 3 times 2, you put 6 in this box. And then you combine like terms to get out of the box. So x squared, 5x, because you do a 3x and a 2x, plus 6. So now you know that this is equal to this. Which again, you could have FOILed this. But the thing about the problem I presented you in the warm-up is now that you have to take this and multiply it by x plus 4 still. Which means you could have done x times x squared times x times 5x, and then distribute the 4 as well. Or we can also do the box method again. So we'll see how easy the box method works for us. So this is 3 by 2, so I need a 3 by 2 box. It doesn't matter whether it's 3 on top or 3 on the side. So there's my 3, there's my 2, so I have an x squared, a positive 5x, a positive 6, an x, and a positive 4. I'm going to multiply it to get inside the box. So x times x squared is x cubed. 5x times x is 5x squared. And then I have a 6x. I have a 4x squared, 20x, and 24. And then I combine like terms. So here we notice these are x squares and these are x's to write my final answer outside of the box. So I have an x cubed plus 9x squared plus 26x plus 24. And that is what happens when I multiply x plus 2 times x plus 3 times x plus 4. So hopefully we now have this quicker tool that will help us multiply different types of polynomials, which is where we're going to go in this lesson. So now that we're done our warm-up, we're going to flip the page. And we're going to recall something else that we've already learned this unit. And it's going to be determining factor form of a polynomial given some zeros. So factored form and zeros. All we have to think about is what's the relationship between factors and zeros. So if I'm given zeros, I should be able to write an equation based off of its factors. So we'll start with f of x equals. You could also start with y equals. So if a 0 is 1, we know that its factor is x minus 1. We've been doing this the whole time. If it's negative 3, that's an x plus 3. If it's 2, that's an x minus 2. And again, we've been doing this. So we shouldn't be too caught off guard when we see that if 0 is 0, its corresponding factor is x. Then we'll have an x plus 1, x minus 4. Still nothing new. We'll look here and here. Not much new is going on. We've got a 5, which gives me an x minus 5. And then it says 2 multiplicity of 3. That means there's 3 2's being zeros, which means there's 3x minus 2's. Also can be written as notice how none of these factors is x minus 3. Just because it's a multiplicity of 3, 3 isn't a 0. It's just saying 2 is written out 3 times. In this next example, we have a fraction. We know how to write fractions into zeros as well, or into factors as well. So just recall x minus 3. We take the denominator, put it next to x, and then subtract the numerator. So 2/3 becomes 3x minus 2. We got an x minus a 7 and an x plus an 8. This is the only place where things change, but no new facts are added. So this says 1 and root 4 are some of the zeros. Well, I know, and you should know too, that radicals, so irrational numbers, have to come in conjugate pairs. So you should know to add negative root 5 to the list. Now, that means we know it's x minus 1. But then when you go to write it, you have an x minus root 5 and an x plus root 5. And a big rule I've been stressing all over is factors should only be written with numbers, no decimals, no radicals, no fractions. So because of that rule, these two must have been gotten from a bigger polynomial. And how do we get that? We get that by multiplication. So you can choose to do the box method or not for this. But I'm going to FOIL, just do x and x. So x squared, negative root 5x plus the square root of 5x. And then square root of 5, negative square root of 5 times negative square root of 5. Well, 5 times 5 under the radical is 25. Square root of 25 is 5. So that just negates the square root. These go away. So you see that when you multiply these together, it's x squared minus 5 and then x minus 1.